Hello, you're listening to Pankaj Rai, and in this video we are going to discuss the first HOTS problem of algebra. So let us begin. It says that if the sum of first p terms of an AP is equal to the sum of first q terms, then we have to show that the sum of its first p plus q terms is 0. And we have to also take care that p should not be equal to q. Okay, so the problem says that the sum of first p terms, let me say it is SP, is equal to the sum of first q terms, so it will be SQ. Then we are supposed to prove that sum of first p plus q terms, S of p plus q, is equal to 0. Okay, so that's what we have to prove. So let us begin by writing the formula for Sn, which is the sum of first n terms. It is given by n by 2, 2a plus n minus 1 times d, where a is the first term of the arithmetic progression and d is the common difference. Now let us begin with what is being given to us. We have been given that SP is equal to SQ. Let us apply the formula for Sn over here. So SP would be p by 2, 2a plus p minus 1 times d, and SQ will be q by 2, 2a plus q minus 1 times d. Now this 2 and 2 will get cancelled. Let us open the bracket. So it will be 2ap plus p times p minus 1 d is equal to 2aq plus q times q minus 1 times d. Alright. Now let's do one thing. Let's take everything to the left hand side. So it will be 2ap. Let's bring this term. So it will be minus 2aq plus this term is p times p minus 1d. Let us bring this term over here. So it will be minus q times q minus 1d is equal to, on the right hand side we will be left with 0. Now over here we can see that 2a is common, so let us take it out. So we will have p minus q, and over here let us take d common. So we will have p times p minus 1 minus q times q minus 1, and this is equal to 0. Now let us open this bracket. So it will be 2a p minus q plus d times, here we will have p square minus p minus q into q, that would be minus q square, and minus q into minus 1, that would become plus q, is equal to 0. Now if you look at this, let us take this p square and minus q square together. So we will have 2a p minus q plus d times, we will have p square minus q square, and let us write minus p and then plus q, the whole bracket is equal to 0. Now over here we can apply the formula of a square minus b square, which says that a square minus b square is equal to a plus b times a minus b. So that is the formula which we are going to use. So we will have 2a p minus q is plus d, p square minus q square will become p plus q into p minus q, and here let us take minus common. So if we will take minus common from here, we will be left with p, and minus is gone common from here, so it will become minus q. The whole bracket is equal to 0. Now if you see here, we are having p minus q as common, so let us take it out. So it will be 2a times p minus q plus d, we are having p minus q common, and within the bracket we are having this term which is p plus q, and this complete term is gone, so we are left with minus 1, the whole equal to 0. Now if you see that p minus q is common from both the terms, so let us take it out. So we will have p minus q common, and then we will have 2a over here plus d times, and here we will be left with this bracket which is p plus q minus 1, and this is equal to 0. Now we are having that the product of two terms is 0, this bracket and this bracket. So either of the bracket could be 0, so either p minus q is 0, or we are having 2a plus d times p plus q minus 1 equal to 0. But if first term, which is if p minus q is 0, then p will be equal to q. But we have been given that p should not be equal to q. So that confirms 2a plus d times p plus q minus 1 is equal to 0. Now let me write it down over the next page. So we are having that 2a plus d times p plus q minus 1 is equal to 0. This is what we have got. Let us name it as equation number 1. Now we have to prove that s of p plus q is equal to 0. So let me begin with the LHS, which says that s of p plus q, which is the sum of first p plus q terms. So it will be given by formula of Sn, which is n by 2. So it will be p plus q by 2, 2a plus p plus q minus 1 the whole into d. Now if you see over here that p plus q by 2 into this bracket, this is exactly same as this. So it will be into 0. Now this is coming from the first equation which we have just derived. So this will be p plus q by 2 the whole into 0 will become equal to 0, and that is equal to RHS. So we have proved that s of p plus q is equal to 0. Now what is the meaning of this term, that if we are having that if SP is equal to SQ, then S of P plus Q is equal to 0. What is the meaning of it? So let me take an example of a AP which is minus 6, minus 4, minus 2, 0, 2, 4 and 6. So this is an AP where the first term is minus 6 and the common difference is minus 2. Now if you carefully see over here, let's say that the sum of first two terms, is S2 and it is given as minus 10, minus 6, minus 4. And if you look at the sum of first 5 terms, that will also be equal to minus 10, because minus 2 plus 0 plus 2 will be equal to 0, so that will not make any difference to the sum. So S of 5, the sum of first 5 terms, is also equal to minus 10. So we are getting that S2 is equal to S5. So if S2 is equal to S5, then according to this we should have S of 2 plus 5, which is S7, and it should be equal to 0. So let us see, is S7 equal to 0? S7 is the sum of first 7 terms. Now over here if you see, these are the first 7 terms and the sum of all of them is actually equal to 0, because minus 6 and 6 are getting cancelled out, minus 4 and 4, minus 2 and 2. So we are getting that S7 is equal to 0. So that is the meaning, that if we are having SP is equal to SQ and P and Q should not be equal, here we are having 2 terms and 5 terms, then we are having that S of P plus Q is equal to 0. Thank you very much.